An object travels with increasing speed along a straight path. The object's speed is recorded every 2 seconds. Here's a table that shows the speed measured in feet per second every 2 seconds for 10 seconds. And here's a graph that's plotting the measurements. And we want to figure out a lower estimate and an upper estimate for the distance traveled. Now, since the object is traveling with increasing speed, I know that for the first 2 seconds, it couldn't have gone any less than 10 feet per second. So if I want a lower estimate, I'm going to assume that the object traveled at 10 feet per second for the first 2 seconds. To find the distance traveled during that 2 seconds, I can multiply 2 seconds times 10 feet per second. And what I'm really doing is finding the area of this rectangle right here. Then between 2 seconds and 4 seconds, I'm going to assume that the object traveled at 30.9 feet per second. So to find the distance there, I would do 2 seconds times 30.9 feet per second, and that would be the same thing as finding the area of this rectangle. For the next 2 seconds, I can find the distance by multiplying 2 seconds times 40.6 feet per second, and then that would be the same as the area of this rectangle. Then I have 2 seconds times 48.1 feet per second, and that would be the same as this rectangle. And finally, I would have 2 seconds times 54.4 feet per second, and that would be the same as this rectangle. And when I do this calculation, I end up getting a lower estimate of 368 feet. Now let's look at the upper estimate. For the upper estimate, I know that in the first 2 seconds, the object couldn't have traveled more than 30.9 feet per second because the object is traveling with increasing speed. And if it went above 30.9 feet per second in the first 2 seconds, that means it would have had to decrease its speed back down to 30.9 feet per second by the time it got to 2 seconds. And that can't happen. So for the first 2 seconds, the distance traveled would be 2 seconds times 30.9 feet per second. And that's the same as that first rectangle with this extra rectangle added in. So what I'm really doing is calculating the area of these 2 rectangles. Between 2 seconds and 4 seconds, I'm going to assume that the object traveled at 40.6 feet per second, and so the distance would be 2 seconds times 40.6 feet per second. And that would be the same thing as adding in this little rectangle. Next, I have 2 seconds times 48.1 feet per second, and that's the same as adding in this rectangle. Then I have 2 seconds times 54.4 feet per second, and I'm going to add in this rectangle. And finally, I have 2 seconds times 60 feet per second, and that adds in this rectangle. And when I do the calculation, I get 468 feet. So I have my lower estimate, that's 368 feet. I have my upper estimate, that's 468 feet. The difference between these estimates, that would be 468 feet minus 368 feet, that's 100 feet. But there's a way of visualizing this. Imagine I take all these extra rectangles and stack them on top of each other, like this. This represents the difference between the estimates. It was the little bit extra that I added in when I calculated the upper estimate. Now I can calculate the area of this figure. It has a height of 50 feet per second. That's because the largest speed that I had was 60 feet per second, and the smallest was 10 feet per second, and 60 minus 10 is 50. It has a width of 2 seconds. That's because I took measurements every 2 seconds. And so the area would be 2 seconds times 50 feet per second, or 100 feet. That's my difference between the estimates. Now suppose that we record the object's speed every second. So here's a table of values, and here is a graph with the values plotted. And we're going to go through the same thing. So first, the lower estimate. So for the first second, my lower estimate would be 1 second times 10 feet per second, and that's the same thing as the area of this rectangle. And since you get the idea, I'm going to go through these quickly. Next, we have 24 feet per second, that's this rectangle, 30.9 feet per second, that's this rectangle, 36.1, that's this one, 40.6, that's this rectangle, 44.5, that's this rectangle, 48.1, that's this rectangle, 51.3, that's this rectangle, 54.4 gives me this rectangle, and finally 57.3 gives me this rectangle. And when I calculate this, I get a lower estimate of 397.2 feet. For the upper estimate, in the first 1 second, I'm going to assume that the object traveled at 24 feet per second, and that's the same thing as the area of that first rectangle plus this extra little bit added on. And again, I'll go through the rest of these quickly. Next, we have 30.9 feet per second. That adds in this rectangle. 36.1, that adds in this one. 40.6 adds this one. 44.5 adds that one. 48.1 adds this rectangle. 51.3 adds this rectangle. 54.4 adds in this one. 57.3 adds in that one. And finally, 60 feet per second adds in this little rectangle up top. And when I do this calculation, I get 447.2 feet for my upper estimate. So now I have my lower estimate, 397.2 feet. I have my upper estimate, 447.2 feet. And I have the difference between the estimates. That's 447.2 feet minus 397.2 feet, and that's 50 feet. So again, we can look at this visually. You can imagine stacking all of the lighter colored rectangles on top of one another. And this figure that's created represents the difference between the estimates. That's because when I calculated the upper estimate, I added in these extra rectangles. So now, to find the difference between the estimates from this figure, I want to calculate the area of the figure. So it has a height of 50 feet per second. Again, that's because my largest recorded speed was 60 feet per second and my smallest was 10 feet per second. And so the difference between those, 60 minus 10, is 50 feet per second. Since I took measurements every 1 second, the width of this figure is 1 second. So to get the area of this figure, that would be 1 second times 50 feet per second, and that's 50 feet. And that's the difference between my estimates. Finally, what if the object's speed is recorded every half a second? So here's a table of values, and here again is a graph. And let's look at the difference between the estimates. So when I took measurements every 2 seconds, the difference between the estimates was 100 feet. And then when I took measurements every 1 second, the difference was 50 feet. So my question for you is, what is the difference between the upper and lower estimates of the distance traveled when measurements are made every half a second?